Hello, gonna do a Leetcode live stream. This question's a little too hard for me to start by saying that. I don't have all the string methods memorized good enough to knock this out very easily. But anyway, I do have thoughts on what you'd want to do. So it says, let's see if we can make this a little bigger. Alright. Minimum time to make rope colorful. Alice has N balloons arranged on a rope. You are given a zero-indexed string, colors, where color sub-I is the color of the IF balloon. Alice wants the rope to be colorful. She does not want two consecutive balloons to be of the same color, so she asks Bob for help. Bob can remove some balloons from the rope to make it colorful. You're given a zero-index integer array named needed time, where needed time sub I is the time in seconds that Bob needs to remove the IF balloon from the rope. Return the minimum time Bob needs to make the rope colorful. This might almost be sort of easy, but there's probably some edge cases and tricks that I'm not thinking of right now. But what I would say to solve this in the most basic way, and there's probably smarter, better ways, is you would, whenever there's a string of numbers that are next to, or letters, they're all lowercase letters, the constraint says. Colors contain only lowercase English letters, and the other constraints aren't super large either. So anyway, though, so if you have the same letter next to each other in this string, then what you want to do is tally up the lowest needed time of those same characters so that you can get the minimum time that Bob needs to make the rope colorful. Because those are the ones you would be removing. It's the ones that have the lowest number. Like this needed time array is sorted, but they're not necessarily going to be sorted. This example is also sorted. This example is not sorted though. So yeah, nowhere did it say it would be sorted. So that's how I would try to do it. Alright, so let's take a look at it and make an attempt on writing code that would do that. But I gotta tell you, I don't know how to. I don't know the exact right way to write this code to do what I just said. So like there's different ways to do what I just said to do. And even if you did do what I just said in code, there might be edge cases where you're not thinking of something. And also, let's see, does it wrap around? It doesn't say that. So like, I'm not sure, but I'm wondering. Oh yeah, no, that's fine. It doesn't wrap around because this example, this one example shows. Oh, this third example, yeah. Okay, so A B A. So in order to make that correct, you have to remove the first A and the last A because the time needed for for those two particular A's is 1. So that's your lowest time needed here. And 1 plus 1 is 2. So that is the correct answer. So yeah, it doesn't wrap around. This example points that out. That's not an issue you're going to need to concern yourself with, because the correct string would then be ABA. Okay, so if there's two chars in a row, you want to tally up the lowest needed time for those. And yeah, I just don't know how to do this. So let's see if I've done this before. So yeah, I've done this before. December 27th of 2023. Whew, it's been a while. Okay, so let's take a look at that, because yeah, I don't know what to do. I would say you might be better off using, you might end up using like a tree map or something. And, but I don't know. But yeah, we'll try to get better code than what I did previously. I'm going to go ahead and take a shot at it a little bit before I look at my previous solution. But yeah, that's been like 2 years ago. Yeah, I don't remember doing this. Anyway, it does seem kind of familiar though. Okay, so we need indexes. Uh, huh. So we're gonna need well, let's make the answer variable. So we'll call it int minimum time, or min time, let's say. You don't want to rename it the same thing as the like min cost. This is the exact same thing as your method or function or whatever that would be called. That would probably mess you up. So you want it to be a little different, at least. This is probably different enough. Min time equals 0. I think we will do a for I loop here. I like it putting this next to it. Okay. Oh yeah, let's get it in. Let's get the length of the array. I like doing that a lot of times. Makes life easier. Okay. So I less than n, I plus plus, and then now what? This is where I don't know all the. There's so many string functions and stuff, and unless you do something like every day, you know, you shouldn't beat yourself up too much for not remembering it, in my opinion. And I don't use string stuff every day, and I prefer like int array type stuff. And I don't know all those methods and functions memorized or anything either. But it would be like let's see. Well, you'd want to if um, colors. Let's see, char at. I think char at is something here. Hmm. I think there's a way to do it without like turning the string colors into a char array, which would be another way to do it. But I don't know. We'll try this, but I don't think it's going to work. I don't think this is quite right either. But it'd be something like this. I think the C is little c here in this case, but I'm not sure. And maybe the A's big. Okay, so if I had I plus 1, then min time equals math.min. This gives you the minimum of two things that you're comparing. So in this case, we would want to compare the values at needed time at I and I plus 1, and you'd want the minimum one, so that's why you use math.min. And you would just compare it similarly, like I and I plus 1, I think, would be the way to go. Alright, let's see if this works. I don't think it's going to. And actually, this should be plus equals because you're tallying it up. But this is a good start of what what the solution might be. It's a good general notion, but I doubt I have it written correctly. Okay. If char at colors, I think you have to do 2 char array or something. I'm not sure. Char at. Alright. Rather than consulting my solution still, I'm going to give this to AI and get the correct way to do this sort of thing. And see if I can get this code dialed in a little better before I see what my previous solution was. So I'll ask the universe. Okay. String.char app method. Okay. Up to, oh yeah. I had my for loop too long since I'm doing +1. Yeah. That's something I didn't think of there. Alright. I'm going to go ahead and put this in my notes for this problem. It's pretty good. Could be helpful. Okay, so yeah, n-1. I should have thought of that. That would have been the next issue I would have been trying to fix. Okay. Huh. Yeah, I was kind of close there. Okay. Neat. Yeah, I've got it backwards. Okay. Wow, I was really close. It's colors.char at. And yeah, I about have it. There we go. And yeah, since you're doing I+1, you're going to have to do n-1 because you don't want to go all the way to the end because this I+1 takes it the comparison to the end. So you'd be going out of bounds if you didn't do that. Okay, so let's see what we have now. Okay, oh my gosh. It solved all 3 cases. Oh my gosh. I figured it wouldn't solve one of them or something, because this is pretty simplistic, and like, what if the two comparisons aren't right next to each other? Yeah, see, I don't think this is gonna work, but I'm gonna submit it and we'll see. But I don't think it'll work. I think it's a little more complicated than that. Oh gosh, that'd be fine if it was sorted, but it's not. So yeah, okay, it is not sorted. Although, yeah, you can't sort that. That'd mess it up. Okay. Okay, so, well, I am, oh, yeah. Okay, so I am going to go ahead and carry on because I do not know what to do here. This is where this medium got just a little bit too complicated for me. So what I'm going to do is see what my previous solution was. But I'm pretty happy I was able to write a solution almost pretty nicely. Although I had charat.colors instead of colors.charat. So I did get that messed up, and I didn't put the n-1. But other than that, I wrote code for this medium that solved all 3 test cases. So that was pretty cool. I'm pretty happy with that overall. And so now I'm going to go ahead and carry on because I don't know. I mean, I just don't know what to do on this. Like, what you would need to do in order for this code to work would be you would need to sort every time this needed time would need to be sorted every time there's like chars in a row. So I guess what you would do is, geez, maybe you could use a 2-pointer and then sort the like subarray of needed time for that length And then this basic code could work just like that. But yeah, I'm not sure. There's some tricky things you can do. Like there's this one problem called like the Dutch flag algorithm where they have like three colors in a row. You could almost do like a little mini sort on it potentially, but I don't know if that would help either. So anyway, I'm wanting to get a Helldiver string going. So I'm pretty happy though that I was able to get the code dialed in this well already. Let's see what the submission says though from 2 years ago. Oh wait. Let's get that wrong answer and get that in my notes because yeah, it's pretty good. Let's get that in here. Okay. And then I'm going to get a better solution than what the solution from 2 years ago was. Let's see what we did here though. Okay, initialize the minimum total to 0, yeah. Iterate through the balloons, yeah. I'm all anyway, yeah, that's weird. This for loop doesn't have the I++ at the end. So clearly it's going to be doing that down here, yeah. Inside a while loop. Okay. So iterate through the balloons. Initialize the current color and the maximum time for a single balloon. Char current color equals char I. Int max time equals 0. Int total time equals 0. Process consecutive balloons with the same color. Yeah. So this is how they're processing consecutive balloons of the same color. I less than colors length, while I less than colors length, and colors at char of I equals current color. But current color equals colors at char of I. Seems weird. Total time plus equals needed time. Okay. There's maximum time for a single loop. Max time equals max time or needed time. Jeez. I plus plus. Then that's the while loop. And then subtract the minimum time to keep the balloon and the rest of the minimum. Something. Min time plus equals total time max time. Turn the minimum time required. Actually, that's pretty good because that way you don't need to sort um, the the streak of same letters. So actually, that does make sense in general. That's a pretty good general notion right there, even though it is a little confusing to me. And I don't, I think it could be clearer and simpler than that. Okay, so how does this perform? Not really good. It's really good on memory, not really good on runtime. So I'm going to go ahead and copy this and put it in my current notes for this problem. But I'm going to use the code I made and ask Bard for a better solution. I bet it'll come up with a better solution than this one right here that I have from 2 years ago. With all this commentary and how it's sort of confusing, but it does make some sense because that helps overcome needing to sort the streaks of same colors in order to like simplify the code. Um, but it's clear to me that this was an AI answer. And AI wasn't as good 2 years ago as it is now. So this will be interesting. I bet the I bet if I give it what I've got here, that AI will come up with a better solution for me. But I don't know. Okay, so I'm going to build the question for Bard, because I like Bard in this situation. Sometimes I use Ask Universe or different AIs, it depends. But for this, I'm wanting to use Bard. Okay. But yeah, there's this new Helldivers loadout I'm wanting to play tonight, try out. But I could probably about after seeing this old two year ago solution, I could probably just about get this code working for it by doing the exact same thing, pretty much. But I would rather have a better solution that might be more clear, which I think Bard can help explain and make it clearer to me. Bard's really good at that, in my opinion. Bard's like my favorite AI coding helper, pretty much. Okay, so then this, let's see, okay, we'll do this. We'll do this and adjust it. This Java code solves question below for examples. For the 3 examples. But not for other test cases because the streaks of chars not sorted. One solution is to total the streak and subtract. Okay, total the streak and subtract. Let's see, what was it? Let's see, what did this code do that did it? It gets the total time. Needed time. Total time plus equals needed time. Oh gosh. Yeah, I don't want to give it this code though, because this is what's confusing to me, like the way the names of stuff. But what it's essentially doing is calculates the total time for that set of balloons. And then what's it do? Maybe down here. Yeah, right here. Okay. So the minimum time would be plus equal total time minus the max time. Minimum time would be total time minus the max time. We'll write it like that. Bart will probably know what I'm talking about. Bart is so smart. Okay. Where's that? Where am I at up here? Subtract max time for a streak from total time. Is that what it was? Minimum time plus equals total time minus max time. Oh, I have that backwards. Okay. So yeah, switch these around. Yeah, Claude will probably know what I'm talking about and come up with a better idea, would be my guess. We will see, though. It'll be interesting to find out if Claude knows what I'm talking about there and what a smarter, better solution might be. Okay. I'll go ahead and start a new chat. Okay, let's give it a shot. Good evening, Jeffrey. Okay. Yeah, there's got to be a faster, smarter, better way to do this. Because the performance of that code from 2 years ago is in the bottom, like 34% or whatever it was. So there's clearly some better, way better solutions. Everything's trick-based solution using some there are consecutive streaks of 3 plus identicals because it doesn't properly track which balloon to keep. Yeah, it's just comparing one next to it. So, better solution, streak-based, most intuitive. Oh, so this uses a double while instead of a 4 with a while. But it's the same, it looks the same, and it seems seems more clear and understandable than that previous solution. But it would probably perform the same way, would be my guess. Ooh, here we go. Optimized single pass solution. All right. Yeah, that's going to be the good one. Okay. I'm going to go ahead and add that to the notes. I bet it's going to work too. I have confidence in that fastest solution. I bet it's going to be really good. So I'm going to go ahead and do this solution first. That's more like what I had, the streak-based solution, most intuitive. That was what my thinking was leading me to on it. But I want to dig into that single pass fastest solution. See what's the trick there. Okay, let's take a look at this though. Yeah, it's doing the same thing. It's doing the same thing as my previous solution. So from 2 years ago. So I'm betting it's going to be very similar performance. Yeah, that works. Okay. Yeah. Okay. Oh, it's worse performance. Or probably what happened was 2 years ago, that performance was better compared to the other solutions that were uh, given. But now, since then, there's been a lot more better solutions given than that streak-based solution. So now it comparatively performs a lot lower. That's probably what's happening, but it's probably, the same. Like if I ran that other old code, it would probably say the same thing. Let's find out. I'm curious. Okay, so this old solution says 32%, 94 memory. Let's take that and put it in here and run it. Yeah. Okay, so now, how will this perform now? Let's see. Hmm. So, yeah, they must be slightly different. Or, this stuff, who knows. But actually, it's much faster comparatively this time than before. And much worse on memory? That's bizarre. I wouldn't have expected that. Okay, anyway. Now let's try this single pass solution and dig into that. What's going on here and why is this such a good solution? Let's see if I can learn something from this. Let's go ahead and dig into it first. I'm going to go ahead and, well, let's make sure it works. Yeah. Okay, it worked for the 3 test cases anyway. Okay. Let's go ahead and make it big and do a little cutout on it. In case I want to make a YouTube short for it or something. I might not. It's not shaped right for a YouTube short probably. Okay, so where am I? That's the previous one or something. Okay, here we go. Let's get this generator 1578. Hopefully this will. But anyway, let's dig into this now that I can see it good. Although my thing's probably blocking some of it or something. Let's see if I can tell. Does this show? If I show the preview, it would show maybe. Eh, I don't know. Okay, going back. Anyway, int min time equals 0. Uh, for color sleeve equals 1. Okay. So in this case, they're starting at 1 and comparing I and I minus 1 rather than starting at 0 and cutting it a minus 1 from the length and doing I and I plus 1. So yeah, that's an alternative way to do that. That's pretty good actually. I kind of like that. Remove, it's the same thing though. Remove the balloon with the smaller time. Min time plus equals math min needed time minus 1. Yeah. Needed time sub I equals math max needed time sub I needed time sub I minus 1. Keep the one with the larger time for the next comparison, right? Yeah. So that's how you'd do that. Oh, okay. Yep, that's pretty good. I really like that. Dang. Needed time. Max needed time sub I. Huh. Wow. So this is like in place using the needed time int array and just moving the max time along for comparisons as you do it. So that is pretty cool. It's a little mind bending for me, but but it's pretty cool. Oh gosh. And that's why you might have to do I and I minus 1 method on this as well. Or would it work the other way? Oof, I'm not sure. Tempted to try it and find out. But anyway, let's make sure this works and check out its oh, that's so cool though. I really like that. Dang. So smart. But it's, I mean, it seems kind of simple and obvious or something, but dang, that's actually really clever. Oh gosh. Keep the one with the larger time for the next comparison by just assigning it. And then the next time through the loop, it would have the max time assigned there. And the min time don't matter because this happens before that and would already have tallied that min time. Ah, wow. I love it. That's what I love about coding. It's like, man, so like these subtle genius things that people that are really good at coding probably take for granted. They're like, well, obviously, But no, this is really neat. Okay. Anyway, uh, let's see. Let's see if it works. It looks really small now. I have very bad vision, apparently. I thought it was going to be way faster than that other one, but it's like the same speed as my old code from 2 years ago. What? Where did it go? Ah, there we go. Okay. So yeah, it's the same speed as that code from 2 years ago. It like looks almost exactly the same. It's weird. But anyway, I think this is the neatest way to do it. It's the most easily understandable. And yeah, it's pretty cool. Okay, so what is Claude saying here? Uh, well, Claude says you're right that the current code has an issue. While it might work for some cases, it fails when there are consecutive streaks of 3+ identical colors because it doesn't properly track which balloon to keep. Um, yeah. See, when it's not sorted, it works for when it's sorted to some degree, or in certain cases anyway. But in some cases, when it's not sorted, it will not work correctly. Better solution, most intuitive, streak based. I like this one though, this optimized single pass. Uh, Key insights in solution 2. By updating needed time to be the maximum, we ensure that when comparing with the next balloon, we're always comparing against the kept balloon, the one with max time so far in the streak. Yep, that is so cool how it does that. Like it seems really risky to be um, changing the needed time array. But since the min time plus equals comes before that, it's totally fine to do that in that in that case. So yeah, it's really neat. I really like that. Complexity time O(n) for both solutions, space O(1) for both. Solution 2 is slightly faster due to fewer operations per iteration, but both are excellent. So yeah, I like this. That is really neat. And I'm going to try to keep that in mind as a way for problem solving, like when you're doing comparisons like that. That is really neat. I really like that. Huh. Because yeah, my instinct on how you would have to do that is use like 2 pointers and then sort the streak so that you could um, so that it would be in a sensible, in a logical order, so that you could do simple comparisons. But yeah, that's so smart to add the minimum one and then just reassign the max one for the next comparison. That is so cool. Hmm. Yeah. Okay. Well, I think that's it for now. It's 11:30. I could get some more steps in before midnight. I've got 9,614 so far, but I've got all three of my daily uh, activity achievements for my Samsung Health app. And we started the new Samsung monthly challenge. I think November Moon is what it's called, or something like that. So, all right, well, that's it for tonight's uh, leak, leak code challenge of the day. I did not manage to come up with a drastically faster solution, but I really like this solution a lot better. It's easier to understand, even though it is still a little confusing. And let's dork with it. You know? I mean, it's not going to affect the speed or anything, but let's see what happens if you do it like this. And then change these comparisons to +1. Will it dork it up? Is the key to doing this reassigning it and the comparisons going to be to start to do the I and I minus 1? Or will I and I plus 1 work? That's my question. It is confusing. I'm not sure. Yeah, looks solid. I think it's going to be the same since it did pass the test cases. Nope. So yeah, there was a reason to do the I minus ones. Oh boy. So oh oh gosh, that's hard to understand. Yeah, I'm still a little bit confused by it. By you know, like what is exactly happening here? It is confusing. Okay, let's just do inserts. Oh, you can't do inserts? No? Okay. Change these back. So yeah, it is important to do it in this way. Although, I think I could have kept it the other way if you would have reassigned, maybe you reassign I plus 1 in that case. Like I didn't change that reassigning part. But I don't know. It still probably wouldn't have worked. Alright, alright. Dang it. Let's find out. I don't think this is a good idea. No problem. Nope. Alright. Son of a gun. So yeah, you could do it either way, but I do like it the other way better because yeah, that seems even more confusing and weird to assign needed time to I plus 1. Oh my gosh. Huh. Uh yeah, Leetcode is so like it's like a fancy riddle that it's gonna take a little more time for this to sink in real good on for me here. I'm still feeling a little bit of an understanding gap here. But I really like this solution. That's really neat. Hopefully, if I see another opportunity to use this sort of idea, that I'll be able to do that and be able to understand it better too. Okay. All right. I'm gonna wrap this up, and I'll be back for a hell dive stream. That's enough mind bending Leetcode riddles for tonight. Wow, that's neat though. I was like, wait a second. Yeah, you need to reassign needed time to I plus one if you're going to do it this way. But I like the other way better. Start at one, go to the end of the array, and then assign that to just to I. And then it'd be I minus one for these three. Okay.